Good day everyone, I am Benedicto from BSE 3B Mathematics. So for today's video, we're going to talk about Wilson's Theorem. But before we proceed to our main topic, here's some information about the creator of this theorem. John Wilson is the creator of this theorem, and it was published by his teacher Edward Waring at the year of 1770. Wilson was born on August 6, 1741 at Applewaite, Westmoreland at England, and he died on October 18, 1793 at Kendal, Westmoreland, England at the age of 51. Now let's talk about Wilson's theorem. Wilson's theorem is like Fermat's little theorem that is related to prime number. But in Wilson's theorem, it have the idea of congruent. Now, let's see what is Wilson's theorem. Basically, Wilson's theorem says that a natural number p that is greater than 1 is prime number if and only if p minus 1 factorial modulo p is equal to negative 1 modulo p, or the remainder is equal to p minus 1. If this condition holds true, then the number that you have, which has to be greater than 1, is a prime number. So to those students who forget about the factorial, let me define what it is. Factorial of a positive integers n is the product of all positive numbers or positive integers that are less than or equal to n. And just so you know, the notation for factorial is the exclamation mark. So suppose you have 5 and the factorial of 5 is a product of all the positive integers that are less than or equal to 5. So it is 5 times 4 times 3 times 2 and times 1. And the product is 120. So again, the factorial of a positive integer is the product of all the positive integers that are less than or equal to n, that particular number. So now you know what's factorial. Let's back to Wilson's theorem. It says that a natural number p that is greater than 1 is prime if and only if p minus 1 factorial modulo p is equal to negative 1 modulo p. So let me give you a couple of examples. Suppose you have p is equal to 5. If you want to see whether p is prime or not using Wilson's theorem, all you have to do is to see if this particular formula holds true. So let's take number 5. The formula to check if the number is prime is p minus 1 factorial divided by p, or we can write it as modulo p is equal to negative 1 modulo p. Now let's substitute our given number. So p minus 1 factorial equals to 5 minus 1 factorial, which is equal to 4 factorial. 4 factorial is 4 times 3 times 2 times 1, and its product is 24. And now it is 24 modulo 5 since our p here is 5. So 24 modulo 5 is equal to 4. And as you know, 4 equal to negative 1 modulo 5. And if you don't know why 4 equals to negative 1 modulo 5, it's simply because 24 divided by 5 is 4. And the remainder here is 4. And the thing that you need to do is to minus our p to the remainder. So 4 is the remainder minus to our p, which is 5. Therefore, 4 minus 5 is negative 1. Or we can add our p to negative 1 to get the remainder. 5 minus 1 is 4. Guys, to make it clear, we can also write the 4 modulo 5. But in this case, we have the idea of congruent, which is negative 1 modulo p. That's why 4 modulo 5 is congruent to negative 1 modulo 5. Therefore, by Wilson's theorem, p which is equal to 5 has to be a prime number. And actually, it is a prime number because the only divisor of 5 are 5 and 1. So let me give you another example. So let's take 13 to our next example and let's substitute it to our given formula, which is p minus 1 factorial modulo p is equal to negative 1 modulo p. 13 minus 1 factorial modulo 13 is equal to negative 1 modulo 13. 13 minus 1 factorial is equal to 12 factorial. And 12 factorial is equal to 479,001,600. modulo 13 or divide it by 13. 479,001,600 divided by 13 is equal to 36,846,276. And the remainder here is 12. So 12 is equal to negative 1 modulo 13. So again, let's do what we did earlier. Let's add our p to negative 1. So negative 1 plus 13 is 12. So we get the remainder of 12 factorial modulo 13, which is 12. So we can say that remainder 12 is congruent to negative 1 modulo 13. And now we can conclude that 13 is a prime number. So as you can see, the Wilson's theorem is a very powerful tool or test that will tell us whether a number that is greater than 1 is prime or not. But nowadays, Fermat's-Noether theorem is the common theorem that most of the students are using to check if the number is prime number. So before I end this video, I want to share and I want you to know that there's a type of primes that are called Wilson primes. And that's are 5, 13, and 153. So that's all for today. I hope you learned something and keep safe everyone.